In the last video, we explored the basic structure of LangGraph, where we learned how nodes and edges form the foundation of state-driven AI workflow. We built a simple example that took an input message, processed it through a node, and returned a response. Now, we'll take that idea one step further. In this video, we'll connect our LangGraph with a real AI model, Google's Gemini 2.5 Flash, and see how a complete interaction loop can be created between a user and an intelligent agent. Here, we'll represent our state as a collection of messages, each message capturing the conversation between a human and the AI. The power of LangGraph truly begins to shine here. Instead of hardcoding a linear sequence of actions, like we often did in LangChain, LangGraph lets us visualize and manage the flow of thought where each step is an independent node that can evolve, connect, or branch dynamically. And by the end of this video, you'll understand how a LangGraph-based chatbot can process user inputs, generate intelligent responses, and maintain conversation flow all through a graphic structure. This marks our first step towards building intelligent agent, multi-step conversational AI systems using LangGraph. So let's get started and see how easy is it to make your AI think in graphs. So we'll proceed to the code. I'm going to create a new file here. I'll name it AI agent agents.ipynb. First of all, start with the import. From typing, I'll import typedict and list. Then from LangGraph.graph, I'll import state graph, start, and end. Then from LangChain underscore core dot messages, I'm going to import human message. Then the model, import chat Google generative AI. Then from .env, I'm going to import load.env. Load the credential first, and then I'm also going to load the model here. So the model is, as I said earlier, it is Gemini 2.5 Flash model. Okay, so let me run this. I'll select the interpreter and then create an agent state here. So the agent state will be of type dict. I'll have one single messages, which will be a list of human message. Then I'll have a function called process. I'll pass in the state, agent state, and then this will again return agent state here. The response will be invoked from the model here. So whatever is present in the state will be passed to the model, and then I'll get the response here. What I'm also going to do is I'm going to append the same state messages dot append response, and I'll also print this. So AI has passed this response dot content. Let me also add a line break here, and finally let me return state here. Now after this, I'll pass state graph, and inside this I'll pass agent state. Let me add a new new node first. So the node name will be process and the function name is process. Let me add two different edges here. So add edge, start to process. Another edge will be from process to end. process to end. Now compile the graph, and then we can see the workflow of our graph here. Okay, run this agent state, and then we can see our graph here, which goes from start to process and then to end. So basically in the process part, what happens is whatever message is being typed by the user is sent to the model or the AI model, and from there the AI model generates a response. Okay, now what we'll have here is a user input. Let me ask for the user message from the user input. Enter your message, and I'll run a loop until the user types exit. So not equals to exit. And I'm going to print the human message. And then my input state is going to be the messages. Its key will be messages, which will be a list of, or I can do it like this. I can code it under human message. Invoke the bot using our input state, and then basically ask for another user input again. So if I run this, I can pass any message here, hello, and then the model has replied me back. Ask what is your name, and then AI replies me back as well. So my each time I enter some text, that will be taken to the model. It will be invoked within our model, and then our model will generate some response here. So this is how we integrate a real world AI into our LangGraph workflow.